All right, well, we are back. I hope you're doing well. I appreciate so many of you being careful with your homework and excuse me, creating just one file and naming it. It saves me so much time if you will just name your homework files so I know what it is I'm grading. All right, 11.8. Very important that you compare and contrast 11.7, which was on permutations, which, do you remember some of the big ideas involving permutations? How do you know when a problem involves permutations? What does it read like, and what does it have you doing? Well, it involves arrangements, right? You're arranging items. Each item can be used only once, and the order makes a difference. If you change up the order, you have a different permutation, a different arrangement. All right, well, let's compare that with combinations. All right, again, after we get done with 11.8, we'll have one more section where we have probabilities involving permutations and combinations. So 11.7, 11.8 are just showing you different ways to find out or to calculate how many ways something can happen. Well, remember, a probability is a ratio between the number of ways something can happen divided by the total number of outcomes. Okay, so keep that in mind. All right, so here's an idea. Say I show you 6 DVDs, and they're up here on a table, and I say, hey, you come on up here and pick any 3 you want, and they're yours. Now, you might not like my DVD options, but that's what happens when you have or had a young girl. Anyways, does this scenario seem like it involves permutations to you? 6 DVDs, you pick 3. Yes? No? Well, I hope you said no, because you're picking 3. I didn't ask you to arrange them in any specific order. I didn't say, show me your first, second, and third choices. I just said pick 3. That group of 3 DVDs is what we call a combination, not a permutation. A permutation would involve arranging them in some order, okay, for display, by preference. But this problem does not say that. It doesn't imply that, okay? So, no, we have what's called a combination in this scenario. And here's the answer. Because you were not arranging them. All right, now the problem didn't involve the word group, or did it? Let's check. No, it just said pick any 3. It didn't say pick a group of 3. But group is a big flashing red light warning that you're doing combinations, not permutations. So for combinations, think you're finding a group, how many groups, and permutations are you're finding arrangements. You're arranging items. Okay? All right, so why don't you read each of these? Maybe we'll do them one at a time. So read number 1. And so here are the requirements for a combination. And it'll start off sounding like a permutation. Each item can still be used only once. It'd be kind of silly to come back here and pick the same movie 3 times, right? That'd be silly. I said, hey, pick any 3, and you pick the same movie, and you put it down, pick it back up, put it down, pick it up, and you walk away with 1. I'd say, all right, you must really like that movie, but I said you could pick 3. So that would be silly, right? So again, each item can be used only once. But now, when finding a number of combinations, we are not interested in arranging the items in any way. No order of finish, no passcodes, no things like that. Okay? For combinations, I want you to think about the word group. Does the word group fit your scenario? Typically, you're doing committees, things like that, for groups versus arrangements, which are permutations. Okay? All right, so why don't you check each of these scenarios out. We'll do A first and decide whether or not you think this involves permutations or combinations. It's very important that you make this distinction because each one has a different formula. Okay? So from a class of 25 students, a group of 5 is chosen to form a debate team. Do you think that's a permutation or a combination? Well, I hope you said combination, because you're not arranging them. You're not picking one for the president. It's just a group. Here you go. Group of 5 chosen for a team. Okay? Committees and teams often involve combinations unless there's a clear distinction in the problem that involves an arrangement or an ordering of some kind. Okay? How about you read letter B and decide on if that is a combination or permutation. A 5-digit passcode is chosen from the numbers 0 through 9 with no repetition. Now, things you should be asking yourself, if I arrange the digits, would I get a different passcode? Would that open up your safe? And it's like, well, no, you have to get it right. The order makes a difference, okay? In letter A, if you wanted to get on this debate team and you were chosen second or third or first or fifth, it wouldn't matter because you made it on the team. There's no ordering. The order doesn't matter at all. But on B, if it's a passcode, the order makes a big difference, right? So this is a permutation because it's a passcode. So you have to think about the situation and ask yourself, is there an ordering of any kind? Is this phone numbers, social security numbers, passcodes, right? These would be, the order would make a difference if I rearrange the numbers. Okay? All right, so here we go. Example 2. Given 4 housemates, Ruth, Elaine, Anna, and Jasmine, list the permutations and combinations that could result when you select 2. All right. Well, we're going to show you permutations first, and then I'll show you the combinations so you can see them side by side. All right. Again, you know the formula for permutations, but you don't know for combinations. Matter of fact, for permutations, it would be this. Permutations for pick 2. So if you want to kind of check that out on your calculator, make sure you remember how to do that. Why don't you take a second, make sure you can find those buttons. Okay. So let me grab my calculator actually. I will need this. So remember, for the TI people, it was, some of you have to put the 4 first, then go find the NPR button, then the 2. If you have the TI calculator, you're just going to go to Math, look for the PRB menu, and then you're going to see the NCR that's coming up for today. That's a combination, but we're just doing a permutation. And 4 and 2, and you get 12. Okay? So the answer here is 12. Now let me show them to you, because this will help you see the difference. So up here are the permutations. Very important that you catch this. Notice how Ruth and Elaine, and over right here, Elaine and Ruth, those are both, now they're crossed out because they are not different combinations. But imagine they're not crossed out yet. Okay, again, I'm not showing you the PowerPoint because the PowerPoint was kind of skipping and not allowing me to do all the features I want, so I'm showing you the result of the slide. So imagine nothing's crossed out here for permutations. Just count them up. You've got 12 different arrangements. Ruth and Elaine and Ruth are different permutations. Okay, I don't know what the situation would be. Maybe house leader and second in charge, right? Maybe Ruth is in charge and then next time Elaine's in charge. Maybe it varies for over 12 days. I don't know. But, okay, so those are 12 different permutations. But notice the combinations. Okay, there's less. There's less. Hopefully that makes sense to you. There's less because you're not arranging them. You're not arranging them. Ruth and Elaine is a group of 2. Whether it's Elaine and Ruth or Ruth and Elaine, both of them are in the house together. A combination doesn't care about ordering. there's always fewer combinations given the same numbers than permutations, because permutations would take Ruth and Elaine and it would look at both orderings, Ruth and Elaine, Elaine and Ruth, two different permutations, but that's only one combination. And if you look through the combinations, there's 6 of them, and each of them have 2 arrangements, so there's your 12 permutations, but only 6 combinations. Okay? So no arranging, no ordering, just groups of 2, and there would be 6. Now I'm not going to try to figure out where the formula comes from. I'm just going to show it to you. Okay? And here it is. Notice if I cover up right here, okay, that is the permutation formula. N factorial over n minus r factorial. That is permutations. Well, we said there's less combinations, and why is that? Well, because you're not counting all the reorderings, right? So how do you end up with less of something? Well, you divide. So divide by r factorial, and that will divide out all the repeats, all the rearrangements that we don't want. But again, you don't ever have to write this out again. You don't have to reproduce this. You don't have to memorize this. You don't need to put this on your formula sheet. All you have to do is write down that with the appropriate numbers, plug it in your calculator, and give me the result. You've got to tell me whether you did NCR or NPR, and then the number. Okay? All right. So let's go back and let's do this problem, combinations, which would be four C2. Out of 4 ladies, I'm selecting 2. I'm making groups of 2. How many groups of 2 are possible from 4? That's what that means. How many groups of 2 are possible from 4? Picking 4. 4 from 2. 4C2. Okay? All right. Well, let's go back into our calculator. I'll let you kind of work along with me. So I'm going to go and find this probability NCR, okay, and 4 and 2. And then I can kind of see them side by side, okay? Now, it's not always half as much. Just in this case, it was half as much, but it's always less, always fewer combinations, okay? So again, math, PRB, and there's your 3, NPR, NCR, and your factorial for finding how many ways to arrange a certain number. 7 of something, 8 of something, 5 of something, 6 of something, 6 books, 5 horses, 7 cars, arranging, using all of them. When you don't use all of them, that's what the NPR. I have 7 cars, but I'm only arranging 5 of them, or only 3 can finish first, second, and third. Okay? Okay. All right, well, let's just work some examples. Hopefully this is making sense. You're seeing the difference. That's important. Read the problem, identify what kind of probability, and then use the right formula. Okay? Very important that even as you're working the homework for this week, you look back and compare to other problems from other homework assignments. Otherwise, you are really going to get confused on the exam. Okay? You've got to start thinking about what is distinguishing about these problems. Okay? All right, there's your formula. And here we go. How many groups of 4 objects are there if you select 2 at a time? So you're going to create groups of 2 from 4. Maybe you've got 4 chairs and you're wondering different ways to make pairs of 2 out in your family room. Okay? Does this sound like a permutation or a combination? Well, I hope you said combination because you're not arranging the chairs. You're just selecting groups of, okay? All right, so we're talking about combination of 4, and I picked 2. Why don't you go to your calculator and figure it out and come back to this slide. Just pause the video and then come back. I'll wait. All right, well, hopefully you realize that that's what we just did, right? That's 4C2. It just worded it differently. I just was wondering if you're paying attention out there. Okay? Yeah, so it's 6. We just did that one. Okay? All right. Let's give him some hair sticking up there. Love the minions. Okay. Example 4. Example 4. Jan has 10 different photos from which she will choose 6 to hang on the wall. How many different ways can she select 6? Very important that you ask yourself combinations or permutations. What do you think? And then, what do you think and why? This is what you need to be asking yourself. Are we arranging? Now, yes, the photos are going to be hung on the wall, and some of us would probably be a little OCD about how we would arrange them, but it doesn't say you're hanging them. It just says you're choosing 6, and then you're going to hang them. So don't read into the problem. Don't make this difficult, okay? You're just choosing 6, almost like the DVDs. So once you choose the 6, then maybe you could say the hanging of them on the wall would be a permutation. But I'm not going to ask you tricky questions on the test, all right? It's going to be pretty clear. And in this case, you're just choosing a group of 6. So definitely the 6 photos. And there's lots of different groups of 6 that you could pick. Lots of them, okay? All you have to do is change one photo and you got yourself a different combination. So combination of 10, pick 6. You got to write that for me, okay? Now go to your calculator and calculate that. Let's go ahead and do that. So math, probability, combination, 10, pick 6. 10, pick 6. 210. 210 what? 210 groups of 6. Okay, that's still an awful lot of possibilities, right? That's why it takes so long to decorate. 210 groups of 6. Okay? All right. I wish I could see your faces and see how you're doing and see if this is making sense. I miss interacting with you. I really do. All right. Example 5. Example 5. At one school, the student government consists of 7 women and 5 men. This is interesting. It's got it's kind of like subgroups, right? How many different committees can be chosen if your committee has to have 3 women and 2 men? Ooh, interesting. So 2 parts to our committee. Now, do you think a committee, does that sound like an arrangement? Like we're arranging men and women on this committee, or does it sound like a group? Well, committees typically are groups, all right? I hope that's what you were thinking. So this will be combinations. Now, the word and is really important in this problem, okay? Every time we have seen and before, okay, it's always meant multiplication. So we have to figure out how many different how many 2-part, we can call them groups, 2-part groups. Okay, we have to have 3 women times the 2 men. Okay, so I have to have 3 women and 2 men. Now, the answer is not, okay, hopefully you didn't think the answer was combination of 12 total and I'm doing groups of 5. That would be groups of 5 if we didn't care about who was in the group, because there are lots of groups of 5, but our 5 may have 5 men, 5 women, 4 men, 4 women. That won't work for us, okay? We have to have 3 women and 2 men. All right, so let's think about this. How many different ways could we have the 3 women part of our committee? Well, that sounds like a little group in and of itself, right? A little combination. Because how many women are there? There's 7. So let's do the women by itself. The women would be a combination of 7. And how many women do we want of the 7? 3. So that would be little groups of 3 women. Okay? And I need to have the same scenario with the men. But I got to guarantee myself at least 2 men. Well, how will I do that? Well, I'll pick little groups from the 5 men. And how many will I pick? 2. So if you notice, I've got the 7 plus the 5. I do end up with 12 total. And my 3 plus the 2 does give me groups of 5. But they're special groups of 5. Special groups of 5 that have to have 3 women and have to have 2 men. Okay? So let's go ahead and do that right on the... I should have done this. It's not 12C5. Okay? Not. Okay? I'm going to erase that now so I have room to write our answer. So you would actually put this, you'd write this down for me, exactly what you see here, and then go to the calculator and simply type that in. Okay? So let's go ahead and let's type that in. So it was probability, combination 7, pick 3, right? Times another combination of 5, pick 2. So 7C3 times 5C2 and 350. So quite a lot of different groups that we could have. 350. Okay, so we'll have 350 such groups. You like the stardust? I think that's cool. Anyways, I lost my blue. I like that blue. I want to bring my blue back here. Right around there. All right, there it is. Okay, so that was kind of a unique problem involving 2 parts. Still groups though, okay? All right, last one. All right, I would like for you to read this problem carefully. I'd like you to try, so in other words, pause the video, work it out, and then come back in and I'll talk you through it. So just go ahead and pause it, work it out in pencil in case you make a mistake. It's very similar to the one we just did. Keyword is and, okay? And work it out. See what you get. Go ahead and pause, and I'll wait for you to come back. All right. Well, you're back, and hopefully you saw this was a combination situation, all right? Unless you're, again, a little OCD about how you choose your food. But it's all going to come to you as a group of items. And we're not saying like it's coming to you in stages, okay, or courses. We're just assuming that you order 3 things and it comes, the main course, your side, and your vegetable or your dessert, whatever, and it comes all at once. Okay, please don't read into the problem. You'll go crazy. All right, so I've got 3 parts to my group. So this is definitely combinations. Okay, this is a 3-part groups. My 3 parts are, I'm choosing from column A, column B, and column C. Kind of like a buffet, I guess. How about that? Okay? All right. So since it is 3 parts, hopefully you were thinking along the lines of almost like the fundamental accounting principle. I'm going to have the first item and from B and from C. So I've got column A, column B, column C. Okay, so column A has 5 choices you can pick from, right? It has 5, and you're picking how many? 3. Okay, let's assume it's small items, otherwise this is an awful big meal. So hopefully your combination was a combination of 5, pick 3. The larger number always goes first. The larger number always goes first. Okay? Times combination of 7, pick 4. You're picking 4 from column B, and you're picking 3 from column C. Column C has 6 choices, and you get to pick 3 of them. Okay? So you work that out, and I probably should have worked on it. Well, I really didn't pause the video. I just waited a couple of seconds for you. So 5, 3, 7, 4, 6, 3. Okay. So math, probability, combination. I'm sorry. 5, 3, 7, 4, 6, 3. 5, 3 times combination 7, 4, I believe. 7, 4, and 6, 3. Times 6, 3. All right, what do you think? Whoa, 7,000. You could be at the buffet a long time. 7,000 groups, 7,000 combinations of food items. A lot of choices, a lot of choices. Okay, I hope you saw the main differences between combinations and the last section, which is permutations. Let me know if you have any struggles, and take care. All right.